Evaluate the following expression. Your answer must be an exact angle in radians or in an interval negative pi over 2 to pi over 2. Okay. So I think the easiest way to do this type of problem, especially when they say your answer must be an exact angle, and they give you, the tan inverse of like square root 3 or a kind of known expression, which I'll talk about in a minute. What is a known expression? The best way to do that I would have solved this problem is I would have had memorized, and I do have memorized common the common trig functions for common angles. And let me write it out for you. So it is expected that you have memorized both the sine and cosine and tangent of 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And actually, this is really not that hard to memorize these, because at any time during a test, I'm going to show you in a second how to quickly fill out this very quickly. So the way it works is with sine, you just start with 0. First of all, you just go 0, 1, 2, 3, 4. Okay, then with cosine, move it down a little bit. A little bit more space in here. Then I just go backwards. So 4, 3, 2, 1, 0. Okay. All right. And then the next step is I put everything over 2. So over 2, 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 over 2. And then one last step, I take the square root of the numerator. And then I go ahead and simplify these. So the square root of 0 is 0, divided by 2 is just 0. So the sine of 0 degrees is 0. The square root of 1 is just 1. So the sine of 30 degrees is just 1/2, simplifies to 1/2. Okay, the square root of 45, or sine of 45 is square root of 2 over 2. And that can't be simplified further, so it just says this. The sine of 60 degrees is square root 3 over 2. That's correct. And sine of 90 degrees is square root of 4 over 2, but square root of 4 is just 2 over 2, which simplifies to be 1. Cosine of 0 square is the same thing. Will simplify to be 1. And then square root of cosine of 30 degrees is square root 3 over 2. Cosine of 45 is square root 2 over 2. And cosine of 60 degrees is square root 1 over 2, which square root of 1 is 1, which reduces to 1/2. And then cosine of 90 degrees is the square root of 0 over 2, but square root of 0 is 0, divided by 2 is 0. Okay, so that I quickly was able to draw out this chart, and now I can kind of look at these and just kind of have a little bit of them memorized. Okay, now let's fill out tangent. So tangent is going to be, it's always sine over cosine. So tangent of 0 is going to be 0 divided by 1, which is just 0. Okay, which makes sense because a line is flat and has no slope at 0. degrees. Okay, so, and then tangent of 30 degrees is going to be 1/2 divided by square root of 3/2. But it so ends up, we can just ignore the 2's because they're just one, there's one in the numerator, one in the denominator, so they just kind of cancel. And so you can just say this answer is 1/√3. So tangent of 30 degrees is 1/√3. And then tangent of 45 degrees is going to be √2/2 over √2/2, which is going to just simplify to be 1. And then tangent of 60 degrees is √3/2 divided by 1/2. But then the 2's are just going to cancel. You're just going to have √3/1, which will just simplify to be √3. And then if you're going to have 0 at tangent of 90 degrees, is going to be 1 divided by 0, which is going to be undefined. So there you go. This is the chart that you kind of really want. They would expect you to have this memorized. And once you have this memorized, and you're kind of once you have this chart kind of memorized, or I would just say be familiar with it and be able to draw it like I've drawn it like right now. But if you're familiar with the numbers in this chart, so there's not really very many numbers in this chart because the same number repeats itself again and again. So like notice how square root 2 is here, square root 2/2 and square root 2/2. Those are both square root 2/2's, right? So that's kind of easy to remember that sine of 45 degrees is square root 2/2 and cosine of 45 degrees is square root 2/2. That's pretty easy. And then the 1/2 occurs, right? It's right here. So sine of 30 is 1/2, and then cosine of 60 is 1/2. And then notice how square root 3/2 is here and here. So, I mean, it looks like there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 different numbers that you have to memorize here. And they're not all different numbers. A lot of them are the same number. You're just over repeated, right? Okay. And then even tangent of 30 is just 1/√3, or if you wanted to, you could rationalize the denominator, but I prefer to just remember 1/√3. And then tangent of 60 is √3. So that's easy to remember because 1/√3 and √3. And if you just kind of look at this chart, maybe just twice, I don't know, every time when you do trigonometry, you come out to get your trigonometry homework, you'll probably just start recognizing these numbers like √3. When they say tangent of √3, you're gonna be like, oh, that √3 sounds familiar. Like I feel like I've seen that connection. I've heard that before. So ideally you would have this memorized. And if you do have this memorized, then when you come to a problem like tangent inverse of √3 is what? Well, then you would have memorized, well, tangent of 60 degrees equals √3. So this answer must be 60 degrees written in radians. It's pi/3. Then they ask, okay, well, what's tangent inverse of -1? Well, this tangent inverse of +1 would have been 45 degrees. So quickly, we have a negative. So all students take calculus. That means all trig functions are positive in this first quadrant. Only sine is positive here, only tangent is positive here, and only cosine is positive there. So where is tangent going to be negative? Well, not here because it's and not here. So tangent is negative in both Q2 and Q4. So they wanted us to report an angle between -pi/2 and +pi/2, which includes the first quadrant and the fourth quadrant. So they're going to want us to report the angle in the first or fourth quadrant. Technically, we could just find the angle in the first quadrant and then we're just going to make it negative because they don't want us to actually, it's going to be in the fourth quadrant, but it's going to be a negative, expressed as a negative angle. So it's easier just to find whatever the angle is in the first quadrant, and then because you're going to go the same direction in the bottom and have, it's just the negative angle, it's just an angle in the other direction. So it's going to be the same angle here and here. So what value, a tangent of what angle equals 1? Well, tangent of 45 degrees equals 1 from our chart. We have it memorized. So that means that in the first quadrant, 45 degrees would have made tangent a 45-degree triangle would be an example of when you would see tangent positive 1. Focusing on a 45-degree angle in this triangle, you would find that when we calculate tangent, it will be negative or positive 1. So if I were to go exactly the same amount of distance down, 45 degrees down, then it would make exactly the same triangle, just in the bottom, just flipped. But that triangle would have the tangent would be negative because our slope here in this fourth quadrant is negative. So it's negative 45, so negative pi over 4. And then this one is the same thing. Tangent inverse of negative root 3. Well, let's just find the tangent inverse of positive root 3, which we already said was pi over 3. So we already know that when you have a 60-degree angle in the first quadrant, that is going to have a tangent of the ratio of the sides are going to be root 3. Well, tangent is negative here in the second quadrant, and they wanted us to report all the angles between, in this first, or I'm sorry, not second, fourth quadrant here. And the triangle that's going to form that same ratio is just going to have the same angle, but it's going to be in this quadrant, and they don't want to say no number bigger than 90, so we have to say this is a negative root 3 over 2, pi over 3. Okay. All right, well, I hope you found this. Okay, so that's one way to handle this problem, is just kind of, having memorized this table, like roughly memorized. You just kind of have to be familiar with those numbers, say 1/2 root 2 over 2, root 3 over 2, 1 over root 3, and root 3. Just say those numbers lots of times, and then you just have to be familiar with those numbers, and you have to recognize, okay, that value I should memorize because I know the tangent of those numbers. So then you can draw your chart, and then you'd find exactly which angle. You know what I mean? But you know that the angle is known, but you just have to draw a chart and find it. So if you kind of have those 1/2 root 2 over 2, root 3 over 2, and 1 over root 3 and root 3. If you have those numbers kind of memorized, then when you draw this chart, you can find out exactly which angle created the ratio of those sides. Okay. So that's one way to attack that particular problem. Now let's look at another way. So if you don't have or strapped for time, then go ahead, turn off the video. But if you would like to see one more way of how to solve this problem, that's one way to do it. So what you could do is you could draw the triangle. Just draw a triangle. The tangent of this triangle, the tangent of some angle is equal to root 3. So that would mean the tangent is equal to you could either say x over y over x. You could say that tangent of some angle is equal to y over x. So that was equal to root 3. So that would mean over 1, that would mean that the y coordinate here is √3, and the x coordinate is 1. And then you could just do, inverse. Well, you wouldn't want to really do inverse tangent, but then you could kind of think about, well, what which one, either a 30, 60, 90 degree triangle or a 45, 45 degree triangle, which one of those does this most resemble? And you have to have memorized your 30, 60, 90 really well, and your 45, 45 really well, and have memorized the ratio of the sides. So this is x, √2. That is the for 45, 45 degree triangle. And this is a 60, 30, 90. The opposite of 30 is x, the opposite of 60 is x √3, and the opposite of the 90 is 2x. So if you have those ratios memorized, then you would kind of recognize that there's just √3 here. So which one does does this particular triangle look more like this, the 30, 60, 90 triangle, or does it look more like the 45, 45? Well, I have a √3, and the 30, 60, 90 has a √3. So one side is x, so x might be equal to 1, and x might be over here might be equal. And if this is x √3, then it would be 1 √3, which would be √3, which it is. So these two sides are in the same ratio format as what we've memorized the sides to be in a 30, 60, 90 triangle. So that would be the indicator that, hey, this is a 30, 60, 90 triangle. And our angle here is 60 degrees. Because across from the 60 is the x √3 side. So how did I know which one to use, whether it was the 45, 45 or the 30, 60, 90? I guess I would say I knew to use the 30, 60, 90 because they both, the triangle that I was trying to figure out had a √3, and the 30, 60, 90 one had a √3. And that's kind of almost always going to happen in this type of problem. It's going to have the √3 in it. And if my original problem had a √2, then I would know that I probably need to use the 45, 45, 90 triangle. Like I said, I think the first way, using the chart, is probably the easier way to solve this problem. I guess with the second problem, let's move to the number 2. If I didn't know the answer right now, and I was just trying to draw a triangle, and I knew that tangent is equal to y over x, and the tangent is equal to -1, I'm going to ignore the negative for a minute. But if we could just say it's equal to +1, what it's telling me is that the y coordinate and the x coordinate are the same. So you have an x here and an x there. Well, wait, if the y coordinate and x coordinate are the same, is that true in a 30, 60, 90 or a 45, 45, 90? It's only true in a 45, 45 degree triangle that you have two sides the same length. So I know right away that this must be a 45, 45 degree triangle. Whenever you have the tangent is equal to 1, then that means that the y coordinate and x coordinate are the same value, or maybe opposite in sign, but the same value. And the only way you can have a triangle that has the same value for two of the sides is if you have a 45, 45 degree triangle. And that kind of makes sense because there's another theorem that's kind of interest may interest you, but the side opposite the largest angle will be the largest side, other than, so That's why the 90 degrees is always their hypotenuse, which is opposite the 90, is always the longest side in your triangle. And then the side opposite the second largest is the second longest, opposite the second largest angle is the second longest side. And then opposite the smallest angle is always the smallest side. So these two angles are the same, so that means that the sides opposite them must be the same, because if they were not the same, then one, if one angle is larger, like if this was 60 degrees and 45, then this side would have to be longer than that side. Okay. All right, I hope that makes sense. All right, have a great day. Bye.